Dear students, you have previously learnt about the concept of surds, their simplified forms, and addition, subtraction, multiplication, and division of like surds. Now we will study the rationalization of surds. Rationalization of surds. If the product of two surds is a rational number, then each surd is called the rationalizing factor of the other. For example, square root of 3 into square root of 3 is equal to square root of 9 equal to 3. So, 3 is a rational number. In this example, we have multiplied square root of 3 by itself, meaning square root of 3 is its own rationalizing factor. Now, let's multiply square root of 3 by 2 square root of 3. Square root of 3 into 2 into square root of 3 is equal to 2 into square root of 3 into square root of 3 is equal to 2 into square root of 9 equal to 2 into 3 equal to 6. 6 is a rational number. In this way, we can obtain infinitely many rationalizing factors of square root of 3, such as 3 into square root of 3, 4 into square root of 3, 5 into square root of 3. Thus, we can say that the rationalizing factor of a given surd is not unique. It has infinite rationalizing factors. In the above example, square root of 3 is the simplest rationalizing factor. Rationalization of the denominator. It is convenient that the denominator of any fraction is a rational number. Therefore, rationalization of the denominator is performed by multiplying both the numerator and the denominator by the rationalizing factor of the denominator. Example: suppose we have to rationalize the denominator of the fraction 2 upon square root of 5. For this, let's multiply both the numerator and the denominator by square root of 5. 2 upon square root of 5 is equal to 2 into square root of 5 upon square root of 5 into square root of 5 is equal to 2 into square root of 5 upon 5. To rationalize the denominator of 3 upon 5 into square root of 7, let's multiply both the numerator and the denominator by square root of 7. 3 upon 5 into square root of 7 multiplied by square root of 7 upon square root of 7 is equal to 3 into square root of 7 upon 5 into 7 equal to 3 into square root of 7 upon 35. Binomial quadratic surds. Expressions such as square root of 2 plus square root of 3, 2 into square root of 5 minus square root of 7, a into square root of x plus b into square root of y, or 3 upon 2 into square root of 5 plus 4 into square root of 6 are binomial quadratic surds. Let's study following examples of multiplication. First example: 4 into square root of 3 plus 3 into square root of 2 multiplied by 8 into square root of 3 minus 9 square root of 2. Solution: 4 square root of 3 plus 3 square root of 2 multiplied by 8 square root of 3 minus 9 square root of 2 equal to 4 square root of 3 into 8 square root of 3 minus 9 square root of 2 plus 3 into square root of 2, 8 into square root of 3 minus 9 square root of 2 equal to 4 into square root of 3 into 8 square root of 3 minus 4 square root of 3 into 9 square root of 2 plus 3 square root of 2 into 8 square root of 3 minus 3 into square root of 2 into 9 into square root of 2 is equal to 32 into 3 minus 36 square root of 6 plus 24 into square root of 6 minus 27 into 2 is equal to 96 minus 12 into square root of 6 minus 54 equal to 42 minus 12 into square root of 6 is equal to 6 into 7 minus 2 into square root of 6. Next example. 5 into square root of 3 plus 4 into square root of 2 multiplied by 5 into square root of 3 minus 4 into square root of 2. Solution. In this example, both binomial surds are in the form of a plus b into a minus b. Therefore, for multiplication, we will use the standard identity a plus b into a minus b is equal to a square minus b square. Therefore, 5 square root of 3 plus 4 square root of 2 multiplied by 5 square root of 3 minus 4 square root of 2 is equal to square of 5 square root of 3 minus square of 4 square root of 2 is equal to 25 into 3 minus 16 into 2 is equal to 75 minus 32 equal to 43. Now 43 is a rational number. The product of the pair of binomial surds 5 square root of 3 plus 4 square root of 2 and 5 square root of 3 minus 4 square root of 2 is a rational number. Such pairs of binomial surds are called conjugate pairs. 3 square root of 2 plus 4 square root of 3 and 3 square root of 2 minus 4 square root of 3 is a conjugate pair of binomial surds. Rationalization of denominator. Rationalization of denominator when it is a binomial surd. We have learned that the product of a binomial surd and its conjugate pair is a rational number. Using this property, let's learn to rationalize denominators which are binomial surds. Example. Suppose we have to rationalize the denominator of 7 upon 4 into square root of 3 plus square root of 5. Solution. The conjugate pair of 4 square root of 3 plus square root of 5 is 4 square root of 3 minus square root of 5. Therefore, for rationalizing the denominator, multiply numerator and denominator by 4 square root of 3 minus square root of 5. Therefore, 7 upon 4 square root of 3 plus square root of 5 is equal to 7 upon 4 square root of 3 plus square root of 5 into 4 square root of 3 minus square root of 5 upon 4 into square root of 3 minus square root of 5 is equal to 7 into 4 into square root of 3 minus square root of 5 upon square of 4 into square root of 3 minus square root of 5, because a plus b into a minus b is equal to a square minus b square is equal to 28 into square root of 3 minus 7 into square root of 5 upon 16 into 3 minus 5 equal to 28 into square root of 3 minus 7 into square root of 5 upon 48 minus 5 equal to 28 into square root of 3 minus 7 into square root of 5 upon 43. Now 43 is a rational number. Another example. Suppose we have to rationalize the denominator of 2 into square root of 3 plus square root of 5 upon 2 into square root of 3 minus square root of 5. Solution. The denominator is the binomial surd 2 into square root of 3 minus square root of 5. The conjugate pair of this binomial surd is 2 into square root of 3 plus square root of 5. Therefore, to rationalize the denominator, let's multiply both the denominator and the numerator by 2 into square root of 3 plus square root of 5. Therefore, 2 into square root of 3 plus square root of 5 upon 2 into square root of 3 minus square root of 5 is equal to 2 into square root of 3 plus square root of 5 upon 2 into square root of 3 minus square root of 5 multiplied by 2 into square root of 3 plus square root of 5 upon 2 into square root of 3 plus square root of 5 is equal to square of 2 into square root of 3 plus square root of 5 upon square of 2 into square root of 3 minus square root of 5, because a plus b into a minus b is equal to a square minus b square, equal to square of 2 into square root of 3 plus 2 into square root of 3 plus square root of 5 upon 12 minus 5, because square of a plus b is equal to a square plus 2ab plus b square is equal to 12 plus 4 into square root of 15 plus 5 upon 12 minus 5 is equal to 17 plus 4 into square root of 15 upon 7. Absolute value. Friends, let's learn the concept of absolute value. Let x be a real number. Then its distance from 0 on the number line is called the absolute value of x. Absolute value of x is represented as this symbol. This symbol is read as the absolute value of x or the modulus of x. Definition of absolute value. If x is greater than 0, then absolute value of x is equal to x. That is, if x is a positive number, then absolute value of x is x. If x is equal to 0, then absolute value of x is 0. That is, if x is 0, then absolute value of x is 0. If x is less than 0, then absolute value of x is equal to minus x. That is, if x is a negative number, then the absolute value of x is opposite of x. Let's see some examples. Absolute value of 5 is equal to 5. Absolute value of 0 is 0. Absolute value of minus 5 is equal to minus of minus 5, that is plus 5. From this, it is evident that the absolute value of any real number is never negative. Let's solve some examples. Find the value of absolute value of 3 minus 7. Solution. Absolute value of 3 minus 7 equal to absolute value of minus 4 equal to minus of minus 4, that is plus 4. Solve. Absolute value of 7 minus x upon 3 equal to 10. Solution. 7 minus x upon 3 is equal to 10. Now, 7 minus x upon 3 is equal to 10, or 7 minus x upon 3 is equal to minus 10. Now let's consider the first value, that is, if 7 minus x upon 3 is equal to 10, then 7 minus x is equal to 30. Therefore, minus x is equal to 30 minus 7. Therefore, minus x is equal to 23. Therefore, x is equal to minus 23. Now, let's consider the second scenario. That is, if 7 minus x upon 3 is equal to minus 10, then 7 minus x is equal to minus 30. Therefore, minus x is equal to minus 30 minus 7. Therefore, minus x is equal to minus 37. Therefore, x is equal to 37. Therefore, x is equal to minus 23, or x is equal to 37. What did we learn? If the product of two surds is a rational number, then each surd is the rationalizing factor of the other. The product of the pair of binomial quadratic surds which are in the form addition and subtraction of two simplest surds is a rational number. Such pair of binomial quadratic surds is called a conjugate pair. Each binomial surd in the conjugate pair is the rationalizing factor of the other. If denominator of a fraction is a surd, then it can be rationalized using its rationalizing factor. The absolute value of a number is defined as if x is greater than 0, then absolute value of x is equal to x. If x is equal to 0, then absolute value of x is equal to 0. And if x is less than 0, then absolute value of x is equal to minus x. The absolute value of any real number is never negative. Exercise. Rationalize the denominator. 9 upon square root of 54. 1 upon 3 square root of 5 minus 4 square root of 7. 3 square root of 2 plus 5 square root of 3 upon 3 square root of 2 minus 5 square root of 3. Multiply. 4 square root of 5 minus 6 to square root of 7 multiplied by 8 square root of 20 plus square root of 7. Square root of 3 multiplied by square root of 5 plus square root of 7. Find the values of absolute value of minus 13 plus 5, absolute value of 11 minus 11, absolute value of minus 18 minus 24 upon 7, absolute value of 4x minus 3. Solve the following examples. Absolute value of 7x minus 11 is equal to 3. Absolute value of 5x minus 8 upon 2 is equal to 1.